Find the domain and range of h of x equal to 1 divided by 1 minus sin x. Here 1 minus sin x is in the denominator, so 1 minus sin x should not be equal to 0. When 1 minus sin x is 0, I have 1 by 0 form, that is infinity, right? So sin x should not be 1. So I have to exclude that values of x for which sin x function gives us 1. Let us see sin x function. The graph of sin x function is this. Here x is 0. Here is pi by 2. Here is pi. Here is 3 pi by 2. Here is 2 pi. And here is 5 pi by 2. Here is minus pi by 2. Minus pi. Minus 3 pi by 2. Minus 2 pi. It is graph of the function y is equals to sin x. You can see sin pi by 2 is 1. Sin 5 pi by 2 is 1. Sin minus 3 pi by 2 is 1. Right? And difference between pi by 2 and 5 pi by 2 is 5 pi by 2 minus pi by 2, which is 4 by 2, which is equals to 2 pi. So difference of these 2 points is 2 pi. And difference of the 2 points pi by 2 and minus 3 pi by 2 minus minus becomes plus. So pi by 2 plus 3 pi by 2 is equals to 4 pi by 2, which is 2 pi. So difference between these 2 points is again 2 pi. Since sin x function is periodic function and it's repeat its cycle, so it means every distance of 2 pi you have a point in which sin x function gives us 1, right? So it means I have to exclude that values of x such that 2n plus 1 by 2 pi. Here I am writing general form because there are infinitely many numbers at which sin x is 1. When n is 0, I have x pi by 2 and sin x by pi by 2 is 1. For n equal to 1, this becomes 2 plus 1 by 2, that is 5 pi by 2, and sin pi by 2 is 1. For n minus 1, I have minus 3 pi by 2 and sin minus 3 pi by 2 is again 1. Right? So in general, I can write values that are required to exclude. Right? So domain of the given function h is all real number except such points. So I can express it in set notation in this form: x belongs to the set of real numbers such that x is not equal to 2n plus 1 by 2 pi. I cannot write it in interval notation because here are infinitely many points which I want to exclude. In this function, sin x function lies between minus 1 to 1. Here minus 1 is included but 1 is not included because if sin x is 1, denominator becomes 0, right? From here I can write two inequalities: minus 1 is less than equal to sin x and sin x is less than 1. Multiply minus 1 on both sides. I have minus sin x is less than equal to 1, and multiply minus 1 on both sides of this inequality. I have minus sin x is greater than minus 1. Combine these two. I have minus 1 is less than minus sin x, and minus sin x is less than equal to 1. Now add 1 on both sides. I have minus 1 plus 1 is less than 1 minus sin x is less than equal to 1 plus 1. This implies 0 is less than 1 minus sin x is less than equal to 2. Right? Now 0 is less than 1 minus sin x is obvious statement because sin x lies between minus 1 to 1 where minus 1 is included but 1 is not included. So it is obvious statement that 0 is less than 1 minus sin x. Now let us consider this part of the inequality. I have 1 minus sin x is less than equal to 2. By taking reciprocal on both sides, I have 1 divided by 1 minus sin x is greater than equal to 1 by 2. And what is it? It is the given function h of x. So what I get now? I get the condition on y. Y is output variables, and output variable represent range. So range of h of x equal to the interval that includes 1 by 2 and all the numbers that are greater than 1 by 2, and I can also write it in set form such that y belongs to set of real numbers such that y is greater than equal to 1 by 2.